itself, there are many components, right? So which are the components? You have C3S, C2S, C3A. Just these are the three more important ones, C3S, C2S, and C3A. Okay? So your responsibility, what is your role? That will be in which page? Page 2, I think. This is page 2. Alright. So you just need to know these three. Understand? C3S, hydrate very fast, make significant contribution to the development of body strength, particularly in the first 14 days. C2S, you will hydrate very slowly. It's really responsible for the development of the strength after about 7 days, then come in, right? Cement rich in C2S will have greater resistance to chemical impact. Okay. C3A responsible for the settling of cement. However, if this hydration is not retarded by adding sufficient gypsum, the cement will steam within minutes after mixing, and is termed as fresh set. Cement rich in C3A are susceptible to sulfur attack. So far, okay, these three?
Yeah.
Anything you don't understand here? Anything you don't understand about these three? No problem? No problem. Okay, page 2. In front also here, I think I tested you before, right? What do you mean by hydration? Have you been tested? When cement come in contact with water, the water particles will react with individual compounds. These products in time produce a very mass film, which gives cement a bonding property, strength, hardness. So this process is termed as hydration. So you must go and describe all these, right? Bonding property, strength, hardness. Okay? So this process is termed as hydration. Okay? Individual compound have different rate of hydration, the characteristic of which determine many properties of cement. Yeah, this one don't need to know. Stop, just stop at hydration here. Here. Okay? So this is asking you to explain the terms of hydration. So basically, it's this whole page. Okay? Is it okay? Okay. Actually, you also have to mention the heat, right? Because during the hydration, it will be what? Heat produced, right? Okay. And then the heat generator depends on the type of cement, fineness of cement, and temperature of the fuel. Okay? If the heat generator is not rapidly dissipated means that the heat got to be dismissed faster. If not, then you will have a problem because a lot of heat will get trapped inside the concrete. Okay? So a significant rise in the concrete temperature can occur. And then this, especially the massive concrete structure. Remember we talked about massive concrete structures. Then inside very hot, you want to expand more, and then around the edge of the concrete, the temperature is not so high as compared to the temperature inside, so it will expand less. So inside expand more, outside expand less. You have differential expansion that lead to stress, and stress will cause crack. So once you have massive concrete structure, a lot of concrete one, like dam, all this, then this type of problem is very, very serious. So you have to manage the heat, right? If not, inside got crack, then especially like for example water dam, it's supposed to retain the water, and then if your concrete inside got cracks, the water will go in, and that will be a problem already. So heat management is very important for massive concrete structures. Okay, okay. Understand? Okay, another topic is aggregate. So for aggregate, this example very important, right? Because I keep showing that these are the examples you have after you have done the sheet analysis. You want to see whether the aggregate grading is well graded or not, right? Then finally you plot the curve like that. This will show that the aggregate is well graded. That means various sizes are distributed so-called continuously. Like you want to find whatever sizes they are still there. So this will show you the well graded grading. If it is not well graded, like simple example here, there will be a gap graded. So when you see a graph like that, this will be gap graded. Very easy, right? Just read this point. There are 60% of the aggregate can pass through this opening, right? And then also same thing, there are 60% of the aggregate can pass through this opening. So you can see basically between this zone to this zone of aggregate, there isn't any aggregate there. If not, how can you have the same passing percentage but with different sizes? So here we'll tell you that from this zone of 2.36 size to 10, there isn't any aggregate existing. So that is the gap graded. That means that from 2.36 size, lower one you can find, alright? For aggregate more than 10, you can find, and then this size one, here to here, I cannot find any because it showed it to me that it's the same percentage that pass. So this is an example of get graded. And in the tutorial, you have one question on this, right? And then I want you to plot the graph of percentage passing versus the x-axis of sheaf sizes, right? Then you can see that this is well graded aggregate, well graded aggregate. Sometimes we call it continuous aggregated, continuous graded, continuous graded, or sometimes we call it well graded. So it's good because whatever sizes you also can find. So how to find this graph? You have to come up with your own table. Basically, we'll give you these two columns only, right? The data. Then you must do your own, construct your 3 more columns here. Why you need to have 3 columns here is because finally I want to do this accumulative percentage passing. So once I got this set of data, that will become my y-axis, and then x-axis is this. So you are going to take this point and this point, this point, and this point, just plot it accordingly. So again, I will only give you size, I'll give you aggregate retain. That's it. So I will ask you whether it's graded, well graded, or gap graded. So you have to plot the graph of percentage passing versus sheaf size. And then as a graph, you'll be able to tell whether it is well graded or poorly graded. Remember we said poorly graded got 2 types, right? Poorly graded, you can have either uniformly graded or gap graded. If it is uniformly graded, it means all the sizes are about the same. That is poorly graded. And then if you have gap graded, certain size you don't have, just like this case, certain size you don't have, that is also under poorly graded. So well graded is all the sizes are there, right? So we call it well graded or continuously graded. So you must come up with your 3 columns like that. 1, 2, 3. Why? Because finally you want to take this column as a y-axis. So you yourself must come out with your own column like that and column like that, and then finally get the accurate percentage pass, and then you got the graph. Is it clear? Hello? Yeah. Can This one you don't need to have graph paper, it's just do it on your answer script, just like now like that. Now see, just mark it, and then just put the percentage, and then just draw. You need to have graph paper. Do it on the answer script. Understand? Of course, this answer script for exam is one booklet lah. We don't give you pieces of answer script, so it's one whole booklet. Okay. Same thing, everything must answer inside the booklet. Don't go and write anything on the question paper. I will throw it away. First paper, right? Construction material, is it the first paper? Yeah. What time? Huh? You ask your secretary, so your secretary tell you what? 2 to 4 p.m. At where? Where is the value? Venue means where do you take your examination? Venue.
E31.
E31, huh? Okay, so far any problem? Remember I told you, right, you should not, cheating is a very serious case, huh? If you cheat, then you may get dismissed from the school, huh? Okay, so on that day we don't allow you to have any electronic devices. Of course, our telephone. If you want to bring, can you put it in the off mode and then put it under the table or under the chair. Not allowed to put it on the table. Even you switch it off, also no, not allowed. Huh? Especially smart watch also, you're not allowed to wear smart watch. Okay? Next one is admixture, right? Admixture, page 18, page 17. Sometimes it jumps, so but never mind. When it comes to the correct position, then I will highlight on it. Okay, page 22 here. Okay, as you know, right, for the admission, they give you a lot, right? They can have air and training agent, they can accelerating agent, they can have third one is what? Water repelling, water resistant or water repelling, right? Pigment, pore filler and polysinus, retarder, water reducer or plasticizer, super plasticizer, bonding admixture. All these are the examples of admixture, right? So maybe you can concentrate on this one, pozzolinus. Okay, is it very strange to you? Or are you familiar with this? You are not familiar with this. So be friend with this. The most commonly pozzolinus are the pervasive and PFA. Yeah? Because of their reaction with lime, these materials can improve the durability when added to the concrete. Okay? So actually this lime means cement because cement comes from lime also, right? So here it says that if you add this one with lime, with cement, then this material can improve the durability of the concrete. PFA is the most commonly used artificial pozzolana, and the use of the PFA in the concrete as a partial replacement of the cement. Partial replacement, not 100% to replace cement, but partially replace it. Okay. Of course, you don't need to go and tell me it's now recognized by what. No need. I just say that the PFA can partially replace the cement. Okay. And then the main benefits obtained from the inclusion of the PFA in the fresh concrete. That means that if you add PFA in the concrete, very good. You can do all these things. Increase workability, decrease bleeding, cut down the tendency to segregate, good long-term strength development in hardened concrete, and then and cheaper than cement. So these are all the good things about the PFA. So you must understand the whole paragraph. Understand? Any question want to ask? No, just learn by how to do already, is it? No need to understand the meaning, is it? No question? What is PFA again? PFA what? What is PFA? Polarized fuel ash. Okay. So far okay? Okay, to test the strength of the hardened concrete, right? Test the strength of hardened concrete. Why you don't say to test the strength of fresh concrete? Why you say to test the strength of hardened concrete? Why don't you say to test the strength of fresh concrete? Why? Why? Huh? To test the strength of hardened concrete. Why you don't say to test the strength of fresh concrete? Why?
Fresh still water.
Huh?
Fresh still soft.
Because fresh, the concrete is still soft, right?
Yeah.
Still don't have the strength, right? When do they have the strength? When they
Harden.
become hardened, right?
Yeah.
Okay. So how you test the hardened concrete? You just prepare them into a cube, right? Or prepare them into a cylinder, right? We say that then you put this cube under the crushing machine, right? And then the machine will crush it. Okay. Here the picture show you the sample is not cube, it's cylinder, right? And then I told you that cube is pretty standard, right? But now Singapore don't follow pretty standard already. We follow the European standard, right? There's EN. EN represents European standard. ES represents British standard. But now we all follow British. We all follow European EN, the so-called European standard. So the sample we take is a cylinder, not cube. Okay? But the nature is all about the same one. I put them under a crushing machine, and then the machine will compress the sample, then the sample will crush, and then you can see the strength from the display of the machine. Alright? So these are all destructive tests. Destructive tests in the sense that why you call it destructive? Because you destroy the sample, right? So you call it destructive test. But there's such thing called non-destructive test, right?
Yeah.
Why is non-destructive test? So you don't need to go and crush it, right? You will test the concrete on site. That is so called that is called test in situ, right? When you say test in situ, S-I-T-U, when they say test in situ means that on the site itself, the wall the beam, the floor. They are there,
Yeah.
right? So those are, you go to the site and do the testing on the floor, do the testing on the beam, do the testing on the wall. So those are the non-destructive tests. Huh? So what are the non-destructive tests? I think you have gone through, right? You have rebound, Smith hammer test, you have Vincent clock test, you have
pull-out test, ultrasonic test.
pull-out test,
Ultrasonic
you
test.
have ultrasonic test and all these things, right? Okay. So you got so many this type of tests, got various kind of specific purposes. So in the engineering activities, right? When will you need to use the non-destructive test? Recall or not? Normal one is to prepare a sample, then you send for crushing, and then all those are the sample that crush, we call it destructive. But for the non-destructive, the so-called test in situ, right? Under what kind of situation, what kind of engineering activity, then you need to conduct this test, which is not so commonly because normally when you go to site, you will just do the destructive test. Normally it's not a problem, right? But as far as I say, this one, it's not so common, but under what kind of situation, you need to carry out this type of test, non-destructive test. Under what kind of situation? Aiyo, I never go to tutorial before like that. Go and see your tutorial and pick up, tell me. Under what kind of situation? When? Of course, you go to hardened concrete, right? Hardened concrete. Hardened concrete. What kind of situation you need to have all these non-destructive tests? What takes so long? You attend this tutorial 10 years ago? Where? Of course, you have to go to the hardened concrete, right?
Yes.
Where?
In tutorial number 4.
Number 4?
Yeah.
Number 4 is what?
3 situation whereby in situ testing of
What are the situations?
regular structure inspection, testing to solve for.
Can you speak slower? Your friend is not so good at their English. Okay, first point.
Regular structural inspection.
Regular
Structural inspection.
Structural
Inspection.
inspection, regular structural inspection, just like the PCA stuff. They want to check the building whether they are safe or not safe. They have to come to the building and check. Okay, that you will use a non-destructive test to check any of the elements. Okay, the concrete is already there. All right. Okay, another situation.
Testing to resolve this over concrete quality.
Again, again, what?
Testing to resolve dispute over complete.
So there's a dispute, right?
Yeah.
Then you will go to this. So dispute, it can be like for the concrete cube test, right? You find out that it failed, then there will be a dispute already. So that means when you send a concrete cube test for testing, if everything satisfied, then it's okay. But if the strength is not satisfied, then there will be a dispute already. So the professional engineer have to come to the site and do the testing on site. Understand? Because they don't agree. Like for example, you send the cube test 2 batches. First batch 7 days after, then you send the test. Another batch 28 days you send for the test. Let's say when you 7 days you find that the strength is not what you want to have, then you may alert you already. Then when it comes to 28 days, the strength don't meet the required strength, then there will be a dispute already. So in that case, you have to send somebody to go to the site to test in situ. So the so-called dispute is referring to if the strength does not meet the specific during the concrete cube test. Understand? Okay, third situation.
To assess the structural stability of concrete after a fire.
After fire, right? So actually, after what?
After the structure capability.
So the example is if the building caught fire after that, I don't know whether this structure will be safe or not. The concrete, the strength will drop or all these things a lot. Then we have to send somebody to go to the site to do the testing. Understand? Another one?
Gather data prior to structural renovation.
I don't know, my hearing got problem. To gather data prior to structure renovation. So when it comes to renovation, it's very critical because renovation you need to remove some of the parts, some of the structure away. So after removing away, will you affect the rest of the structures? That because you remove some of the structure away and then you leave the leftover one to take the strength, will it be safe or not? So or down here it says that before you do anything, you must analyze, right? Pyron means before you do any renovation, so you will think, oh, if I take away this piece, will it be okay or not? Alright? So before you do this, you must go and test the structural. What is their strength? Is it okay? Then if it is everything okay, then you can remove those things you have already identified. Of course, you must know if I take away this one, the P will go and calculate the strength, all these things. But they just want to make sure that before I do any renovation work, I want to test all the structures are intact in the sense that they are taking the whatever strength they have, their strengths are there, then I can do the renovation. Because if you don't do it like that, you just take, what happens is, if the building is already got problem, and then now you go and renovate it, then you got more problem coming in, then the building may cause collapse, understand? Okay, what's the next one?
Testing to assess
Diagnostic testing to assess reasons for. So can you explain for me? What is diagnostic? Like the doctor hear your heartbeat, that is diagnostic, right? Examine, investigate, right? That is diagnostic, right? To assess reasons for deterioration. That means that they know that there's a crack, all these things already, right? Then that is the deterioration already because there's a crack. Then I want to know why the crack can happen like that and all these things, right? So we must go to the site and see the symptoms, take the data to test the strength and all these things and see how the strength seriously affected, and then from there you'll be able to judge why the concrete can be so bad and then what is the reason. Just like the doctor will do what? Test your heartbeat, test this, test that, then after that, then they can assess that, hey, maybe you have this problem, and then why you got this problem is because now I'm doing all this testing, collection on your body, whatever data I can get from your body, heartbeat lah, high blood lah, whatever, then finally I can have some analyzing data to know what is the problem in your body. So it's the same logic, understand? Okay lah? Okay, so these kind of things you have to know. Next question what? And that's it for the concrete. Before we go to the second topic, any questions? Huh? No? Go read through, see whether got any problems before I proceed to timber.
So for the concrete test, we only need to remember the test outside or the
Whatever I mentioned,
Everything.
emphasize, then to pay attention to it. Okay, next topic we are talking about is your timber, right? Okay, for timber you will have conversion. So conversion, I think in your test you also mentioned things like that, right? You have tangential cut, you have rim cut, you have step cut, right? Huh? No, I just so actually it's more or less about the same tangential conversion. What is conversion? To cut the timber from a trunk to cut it into marketable size, right? So whatever you see, all the strip of timber, all those are the marketable size, right? And then the trunk is the timber 100% come from there, right? Trunk. Okay. So conversion means to convert the tree to become the marketable size of timber. So that's conversion. So you need to cut lah. There are 3 ways to cut, right? Tangential cut, wave cutting, and slab cutting. So all these things you must know what does it mean lah. Then you also have to draw the picture, right? I think the test you have gone through this, and yeah, and the advantages. All these, is it okay? More or less, it's quite similar to your test. Is it okay? So you must know how to draw all these things. Okay? Tangential cut, rim cutting, and then the slab cutting. And then you must know all the advantages of these various kind of cutting, right? Okay? Any question? Okay, so far any questions about it? Okay, when you do your timber construction, right, you are going to use the so-called wood, right? So what is the problem normally? What is the problem normally? What is the problem normally? Moisture problem? Got moisture problem or not? Got moisture problem or not? Okay.
Split wall. Split wall.
Next one is what problem? Next one is what problem? Timber. First one is moisture problem. Inside water, right? Got any problem. And then what else? Another problem is what? Another problem is your termite problem. You know what's termite? Termite, what's termite? White ants is your termite. Okay, so you need to know is like, okay, is it clear?
Yes.
Okay, so this one is to describe the problem of moisture. Okay, because timber have moisture, right? Unlike steel, right? Steel don't have moisture, right? Okay, so these are the problems, the moisture problems. You will have swelling and shrinkage problem because of moisture, and because of moisture you have decay problem, and then corrosion of metal fastener is because you need, when you want to meet this and this joint together, right, you must have some bolts and nuts or some metal devices to fasten it, right, so that they can join together, right. So what happened? You are using the metal, right? So you will have a corrosion, right? So it's not the real timber problem, but I can say that it's because of you must go together with the timber, the fastener, like for example the bracket and all these things, the equals and all these accessory, you must fasten to make the two timber join together, and then they are of metals, and then if they are metals they have corrosion problem, right? So these are the mainly the problems for moisture that happen, because moisture, the water mixed with the metal, you make the metal corroded faster, right? So generally when I ask you what are the problems that timber will face, and then you will say is the moisture will give you problem, and then you will tell these are the things because of moisture. Okay, so do I need to explain swelling, shrinkage, decay, corrosion of metal fastener? Is it okay? Need to explain or not? I think it's quite self-explanatory, right? Correct? What do you mean by dimensional instability? What do you mean by dimensionally stability? Because swell that get bigger size, strain smaller size. So the dimension keep changing, right? So that is dimensional unstable. What else? Decay means what? Moisture can facilitate fungal decay. They will eat up the fungal, right? The fungal will eat up the timber, right? And then the timber will get decayed, right? And then the strength will get affected. It's just basically all the living things that hide inside the timber will eat up the timber, and then finally the timber will get decayed. Understand? And the next one is, as what I mentioned, high moisture control can cause corrosion of metal connectors and fastener used in the engineering timber product that will weaken the joints and connection. Okay? It's even very easily to get corroded because timber itself got a lot of moisture. So when you use the metal wood to connect the timber, of course, all those metal pieces will have high risk to get corroded because the timber itself got a lot of moisture. When things get corroded, it's because of water plus oxygen, right? So far, okay? Okay, any problem? Because of moisture, and moisture will lead to all these problems. Okay, then the second one I want to discuss is because of the termite. Termite is a white ant. Then I will show you another similar description based on the termite problem. So this one is the so-called moisture problem. Okay. So how about the termite problem is termite problems. Okay, termite problem will lead to what? Structural damage, will lead to cost of prevention, will lead to monitoring and maintenance problem. Alright? Why you said termite problem will lead to the structural damage is because termite can feed on the wood, it will eat up the wood, including the engineering timber, leading to structural damage if infestations are not detected and treated properly. So a common sense is the termite will eat away the wood, then the wood strength definitely will get affected. Okay? So this is the first one. So all this is talking about termite problem will lead to this. Understand? So first one, termite problem will lead to structural damage. And second problem is termite will lead to the costing, right?
Yeah.
Cost. Okay, because you need to prevent the termite attack, then you need to have a lot of costing, right? Okay, so cost of termite implementing effective termite prevention measures, like for example, chemical treatment, physical barrier. Something is quite interesting, physical barrier. You can have constructed something, then the termite will not cross over to go to the timber and attack. So these are the something quite interesting, but there's such thing called physical barriers. It's just like during the wartime, people want to attack your country, so what do? You build a tall wall, people cannot cross over. So people not so easily to go to the other side and attack you, right? And that wall we call it as a physical barrier. Simple example. Okay? So for building it's possible, you can build some physical barriers to prevent the termite from attacking, and it can add to the overall cost of using the timber, engineering timber. So because of you need to handle this termite problem, then you need to do a lot of all these prevention measure, and that will lead to the costing higher. So that's the reason why sometimes if you use a timber product, especially like MET, we mention things like that, they can be costing because very costly because of all this. They have to take care of prevention measure, they have to put in a chemical treatment, that's so-called preservation, they have to build physical barriers, and then finally the overall costing will be more expensive. So this is the problem. Understand? And because of what? Because of you must handle termite, so it becomes a problem. Next one, because of termite, you have to monitor more, maintain more. So regular inspections are needed to detect early sign of termite activities and prevent extensive damage. So because of this one, you have to monitor more frequently, you have to maintain the timber structure more frequently, and that will cause the caustic. Finally, also will say cause the caustic, but this one is just to enlarge it to say that because of termite problem, so if your building is built by MET, what is MET? Mass engineering timber, then you will need to regular inspection and need to have more maintenance. Yeah. So these are all the problems for timber building. Understand? So far okay? Okay. And then next one I'm asking you is, so what are the mitigation? What is mitigation? Huh? What are the things you can make good to that? Okay? Mitigation means things that you can make good to it. Okay? So what are the things you can make good to it? Mitigation. Can anyone imagine how to mitigate? That means that to minimize the thing so that you don't have, you can solve some of the termite problem, some of the moisture problem and things like that. Alright? So we call it mitigation. So what is the mitigation? Yeah, so this is the mitigation. Preservative treatment. Remember, we say that you need to preserve, need to introduce chemical inside. So this is one way to mitigate, right? To manage the problem, to solve the problem. So first measure is to have preservative treatment. So apply preservative that can protect against fungal decay and termite attack. This is the first one. Second, also mentioned previously, you will do a moisture barrier. So install a vapor barrier and ensure adequate ventilation can help manage the moisture level. So they are making use of the environmental factors that is not good to the termite, so that the termite will be scared of that and then it will not come. You know that kind of. So they are making use of the adequate ventilation, right, to cut down the moisture. Usually if you have an environment of high moisture and the ventilation is no good, the air vapor staggered around, then termite will like this kind of environment, right? So how to do something that termite don't like this kind of environment? So down here it says that build a barriers that you install a vapor barriers so that you can ensure that the circulations, ventilations are there, so that you can cut down the moisture level, so that the termite don't like it, then they will leave, they will not stay there. But how to build these vapor barriers? Of course, no need to know lah. You want to know a lot of things you have to know lah. You want to know, then you want to go to the Google and find and go ahead. All right. So it's just that to build a environment that the termite don't like it. So one way is what? To have a good ventilation, so that the moisture will get built up, stagnant there, and then termite will like it. So usually you know, right, termite will like those places that got moisture, high moisture, and don't have much air circulation. If your house got very good air circulation, usually termite will not be making family there. Understand?
Yeah.
Okay, so next one is again the termite management. Using termite resistant timber species or treated timber. Actually, it's quite related to the first one, right? But this one is especially for termite resistance. Okay? Along with the physical barrier. Okay? Just now we have mentioned things like that. Okay? Like metal shift or chemical treatment can prevent termite investigation. So metal shift is just like you build something to block so that the termite will not cross over lah. That is metal shield, right? Understand? Just like you have a shield on top of your head, then when the sun wants to shine on you, you will be protected because there is a shield, right? So this one is the same. The shields there is to make the termite not easily to go across from one area to the other area to get so-called invested. Understand? So these are very actually quite general answers. But if we want to talk you how all the specific things, then you will have more problems. But generally, we just say that use a termite resistant timber species, and then also call the treated timber with preservatives, or build the physical barriers, right? And then this barrier must be of metals, okay? And that can prevent termite infestation. And there's another point. Another point I need to tell you is this point. So just now is 3 points, right? So now 4 points. So now is another point, that is this point. You also need to jot down. This is the 4th point. Okay. Regular maintenance. There's another point, right? Implement a maintenance schedule for inspection and necessary repair can prolong the lifespan of the engineering timber. It's also very general suggestions. That means that you must have more maintenance, regular maintenance. So you can prolong the lifespan of the timber. So that when during the maintenance or inspection, then you can maintain, and then the building will be longer life. All common sense questions. But if I go through, you think you can answer? Cannot. So just pay attention to all this. Understand? So far okay? So this is for timber. Any questions? Is before I go to another topic. That's still right? So far okay? So the third topic will be the steel, right? The steel topic will be what? Okay, for the next topic is talking about steel, right? You have to know things like This one is the page 5, right? Still, the effect of carbon you must know. I think the test we also have mentioned about things like that, right? The effect of steel. So the effect of carbon, because carbon definitely existing in the iron, and then if you want to mix steel, you must get it from iron to mix steel, right? So definitely there will be carbon inside. So you must know the effect of carbon. Okay? So the effect of carbon is what? This one is in page 5. Page 5. Okay? So what is the effect of carbon? The effect of carbon will control the hardness, control the stiffness, and then also will control the strength, control the weakness, as well as controlling the ductility. And that's it. Because the weakness and the resistance to shock is a related thing. You say weakness high means what? Resistance to shock is low or high? Low. If you say the weakness is low, then the resistance to shock load is high. Right? So maybe you don't even need to mention this. So but I think better to mention this so that you will impress me, then I give you one more mark on the kind of thing. So the carbon will have all these things. Inside have good and bad. Not everything good, right? Higher hardness, higher stiffness, higher strength, higher brittleness. That means no good already. Higher brittleness is no good. And then cut down the ductility, good or not? Good. Cut down the ductility is no good, right? Okay. So these are generally the effect of carbon. So far, okay? Then again, I will test you on the corrosion problem. Right? So what is the corrosion problem? Which page? Page 24, right? Okay, so page 24, to prevent corrosion, you need to have production of corrosion resistant alloy, anodic metal coating, chemical treatment, and protective painting. So all these you must describe one. All these you must describe one. Yeah. Of course, the painting, you don't need to tell me what are the various paint. It's very tough for you. Just the first paragraph here talking about the protective painting. So far, is it okay? And remember, when it comes to alloy, right? That means that you have to mix the steel with what? Alloy steel. You have to mix the steel with what? Chromium and copper may not be that critical. The other one more critical is what? Nickel. Copper will do what? Nickel will do what? What is the role of the copper? What is the role of chromium? What is the role of nickel? Chromium will have what? Corrosion resistant. And then nickel will have the strength, build a better strength. Understand? Okay. Here, it will build better strength, and then chromium will give so-called resistance to corrosion. Okay. I think stainless steel got more description on the other page also, right? Which page? I remember got something also. They mentioned about that. What steel here also, right? The more description here. Okay, chromium will give hardness, will give turnover, for example. Okay, maybe you just highlight on the main one. The chromium can give remarkably resistance to corrosion. Okay. Here they never mentioned about nickel. Okay, so basically the main one corrosion because of chromium, and then the higher strength one is because of the nickel. Okay. Okay, so basically you should not be straight to all this because in the test I also ask you to go and study all this. So far, any questions? Okay, look at your tutorial for steel. I think the second tutorial for steel. Tutorial for steel got two, right? Got two steel tutorial, right?
Yeah. Very question.
one talking about different way to introduce a metal coating one. Remember? Which question? 11. That also related. Which question? Last question, Ali. Second last question. Metallic protection coating, right?
Yeah.
Okay. So that is also more detailed one, right? How to introduce a layer of metal that coat the steel. So they will tell you all the various way, right? Okay, so those are the more detailed one to introduce a metal coating to the steel, right? Wait, the last, okay, Okay, next one is talking about the fire protection for steel. So what are the fire protections that you have to take care for your steel? Is it last question also? Is it last question? Fire protection?
Yes.
Last question. Okay, so for fire protection, what do you do? Okay, the last one is talking about we will spray cementitious material on the steel, right? And the other one? Put the steel inside the concrete, right? Okay. And then got one more, got one more. Can you guess what? There's one more. Can you guess? There's one more also together with concrete one. Can you remember? There's something called steel decking. Can you remember? There's one more is the steel decking one. How to protect steel. Okay, composite steel floor system. That means that not 100% using the steel, you are combining the steel with the concrete. That will indirectly considered as one of the method to prevent the steel from getting fire and then lost the strength and all these things, right? Because you have mixed it together with concrete, then it's better. So down here it said a composite steel floor system. For floor using composite steel deck floor with concrete. I think I ever mentioned, right, you have lower layer is steel, on top is concrete. The so-called the steel deck floor. If you don't know, go to Google, look for the image steel deck floor. Because of the concrete there, then they will give you a fire resistant. It's not 100% steel. So the concrete slab acts as a thermal mass that protect the steel from concrete. Remember we said first one you spray cementitious material on the steel, the other one is you cut, you encase the steel inside the concrete, and then this one also related to concrete, you will use the so-called a composite steel floor system. Because as long as concrete is together with the steel, concrete is very bad to transfer heat, so it's very good for firefighting. Steel can transfer heat very well, so it becomes very bad for firefighting. So if you combine them together, then you will cut down the effect of 100% of being steel when it comes to fire. Understand? So now I ask you, you read this one, it should be quite common sense thing. So you can go to Google and see the picture of steel deck floor. Can you see the picture? Steel deck floor. So I tell you what is steel deck floor. I think I showed you before, right? Huh? So these are the steel deck floor. They combine the concrete and the steel together. Understand? They will show the concrete combined together with the what? Or maybe you type the composite steel deck floor lah. Composite steel deck floor with concrete. More detail. Then you see a better picture. If not, after that they just show you the 100% deck steel deck floor, then that is not correct. Because it's a composite. When you say composite means two materials together. One layer is concrete, the other layer is steel. Is it okay? Can you see? Combined together. Okay? You can see people do concreting on the so-called steel deck. Composite steel deck floor, right? Okay, so far okay? Okay, then you will go to the next topic. The rest of the topic will be quite short one. Okay, next topic will be what? Are you going to submit the assignment to me today?
No.
All must submit in paper form, cannot put inside the bright space. I want to see paper form. So when are you going to submit?
Friday.
Sure, Friday you don't submit, that's it already. The next one is bitumen, is it?
Yeah.
Next one is bitumen. Okay, you must know the bitumen property. So what are the bitumen property? Can anyone tell me see what is the bitumen property? Yeah, so what are the bitumen property? Yeah, right, bitumen property, right, this
Yes.
page, right, page 3, right? Bitumen property, excellent resistance to water passage, good adhesion, resistance to exit, good flexibility, that link with the temperature. So the property can vary. That means that it can turn hard, can turn soft, right? Property can be varies, right? Okay, understand? So this is for the bitumen. Okay, next one we talk about can you tell me the property here, which one linked to the softening point? Which one is linked to the softening point?
Good flexibility and
Good flexibility at normal temperature lah. The other one can be suit different application because also talking about hard and soft. So you can turn temperature high to become soft, then low temperature become hard. And then we also have things like, okay lah, so these are the two for, understand? Softening point. And we also have something called cutback bitumen, right? What is cutback bitumen? You rely on the temperature, right? You rely on what? You rely on the volatile vapor, right? Poured in, then it becomes soft. Rather than you heat up, right? Remember, there's cutback bitumen, right? Because there's something like that. So here is just only to tell you that the property can be varied to suit different application. Alright? You want to turn it soft, you can want to make it hard. So usually it's talking about how to make it soft. Either you raise the temperature or you pour the volatile liquid into the bitumen to make it soft. So that one we call it cutback bitumen, remember? Things like that. Okay? And then we also say that the emulsion is like a liquid form, you can spray. So that's why you can see the property can have various stage that can use for different kind of engineering application. So anyway, these are the property you must know for bitumen. Okay? Okay, so far any problem for bitumen? Alright, then after that the next one is talking about what? Next one is talking about bricks, right? So to talk about bricks, okay, so for the brick, actually in the course note they said the difference between the brick and the block is because brick smaller dimension, block bigger dimension. So in terms of productivity, of course, you will use the block rather than the brick, right? Because if you use the brick, you have to lay many rounds. For block, you just lay few rounds because block is bigger dimension in that sense. And then we also mentioned that it can be made of clay, also can be made of concrete, right? If it is clay, then clay big, like if made of concrete, then concrete. But usually blocks are the concrete blocks usually okay, and usually bricks are all the clay brick. Okay, so for clay brick itself, how many type of clay brick you have? Clay brick, what? How many type of clay brick you have? 3. Page 4, right? You have common brick, facing brick, and engineering brick. Okay. I mean the common sense will tell you your common brick for what? Common use. Facing brick for what? For fascia, right? Then for engineering brick is for structure, right? So it's very common sense thing, but you need to. So these are the things you need to know, right? And then hollow block, right? Page 10 here have hollow, right? So hollow means what? The voids can pass through, right through. That means first phase, the bedding phase will can pass through, right? The bedding phase. That means what do you mean by? This one is the bed face, right? On top. How about the bed face below? Also, right?
Yeah.
So when you say hollow, means that from the top of the bed face to the bottom of the bed face all punched through inside air. That's why we call it hollow. Understand? Yeah. So just now we said for page 10 here, something to highlight about hollow. So hollow block. So these are the voids that passing through. They can be shell bed that the so-called the mortar is laid in two stream adjacent to each. Okay, don't worry too much about this one. The strength of the hollow block can be increased by filling the cavities with concrete, especially if the reinforcement is included. Okay, so these are just generally, let's say you want to increase the strength of the hollow core, so-called the hollow brick or rock, then you can fill up the vacancies, the cavities with concrete so that the strength will be better. Understand? So far is it okay? That's on page 11. Alright. Okay, any questions about brick? No, then we will proceed to the next one. Next one will be the last topic, is it? That is polymer, right? Page 11 here, polymer, right? Polymers and fiber reinforced polymer offer many advantages over other materials, but the most appropriate resins must be selected for this. Then, so there's a good thing about this fiber reinforced polymer. About these are the good thing about the fiber reinforced polymer. What do you mean by fiber reinforced polymer? What is the meaning of this one? Fiber reinforced polymer. Polymer means plastic. Fiber reinforced plastic means what? Inside the plastic, you put the fiber to reinforce the plastic. Just like you say that reinforced concrete. Reinforced concrete means what? You put reinforced concrete means it is a concrete. Inside the concrete, you put the steel bar. So we call it steel reinforced concrete, right? Steel reinforced concrete. So here, fiber reinforced polymer means what? It is a plastic. Inside the plastic, you put the fiber. Understand? And then the fiber can be many fiber, right? It can be natural fiber, can be artificial fiber, right? Natural fibers are the come from the plants. All these are resins. All these are the natural fiber. Artificial fibers are glass fiber, steel fiber, and the plastic fiber also. Right? So the fiber can come from plastic also. Right? So these are so-called the fiber reinforced plastic. So why are they so good? So these are the things you need to know. I think it's related to your test also. Test I asked you all to study all this. So all this you must know also. So far is it okay? Now it's 12. It's supposed to dismiss at 12:30, right? 1:30. Okay, basically, so these are all the exam supervision I mentioned. Any questions? That's it already. So what are the things you want to ask? No need to study what? Green material. I never mentioned that. Why? Why do we study? I never mentioned that we study. Was it okay?
Yes.
Is one of the example inside already, just now I mentioned. What are the things that is related to this green material? Can you guess about? Just now also got mentioned already. Although I didn't say opaque green material, they do have. It is under what? PFA. PFA is a green material. PFA is not a green material. It is a green material. Why? PFA is a green material, right? Why? Why PFA is a green material? You can replace cement, right? You don't need so much cement. And that is also considered as part of the green material. Okay? But of course, we still talk about steel is the best for sustainable construction and green material because we can recycle. Concrete, we try not to encourage it, but because it's so commonly used everywhere, so just for the concrete itself, you also can subdivide some of the material which is green. Like for example, you use artificial aggregate, right? There's so-called what? Copper sludge aggregate, right? Washed copper sludge, right? That one you can replace the aggregate. So those are the examples, right? We talk about eco-concrete, all this. Okay. Any other questions? So for those who didn't submit your assignment, you better submit. Must wait until Friday, man. Yeah, you must submit to me in paper form. I don't want to see electronic. How many of you want to submit? None. Only one.
Yeah.
If like Wednesday they can submit, then how to find
Wednesday. You can go to the 10th floor to find me lah. Or go to 10th floor to find me. If you cannot find me, then you just say, oh, your lecturer is Mr. Tan Chi Wee, then they will put the assignment on my
what is still the way until
then that will be okay already.
Until Friday.
Understand?
it's Friday due. So
Actually, this coming Friday, I don't know whether you all need to come or not. If you all don't need to come, then no need to come. No? In fact, I have already finished your revision already. You all want to come or not Friday?
Yes,